So today we're still in chapter 3, and today we're going to start, actually we started part 2 last time, which was solving the problems, and now we're going to get to section 5, which is equations with the variable on both sides. So far everything we've learned has had our variable on one side of the equation. So you only had a variable on one side, and then there was something else on the other side. And now we're going to start seeing variables on both sides of the equation. So for example, you might have something that looks like this. 6x equals 4x plus 18. So before you can solve any equation like this, and before you can begin to solve it, you have to have the variable on one side of the equal sign. You have to have the variable on one side of the equation. It doesn't matter which side it's on, although you'll find I favor having the variable on the left side, because that's the way I'm used to it. There's nothing necessarily wrong with keeping your variable on the right side, but I think it's easier to work with if it's on the left side. So when I do the examples, you'll see me do it on the left side. Okay? So in order to move something from one side to the other, you can use the addition property of equality and the subtraction property of equality. So as long as you do the same thing to both sides of your equation, you still get a true statement. It still stays equals. It still stays an equation. So when there's no signs in front of these, we sort of understand these are both plus. So this is a positive 4x and a positive 6x, right? Because if it was negative, there would be a minus sign in front. It would be minus 4x. So because there's no sign, you sort of know that it's positive. And so to get them off the right side, to get a variable off the right side of the equation, I'm just going to subtract, do the inverse of whatever my variable is. So if I subtract 4x from each side, I pick 4x because plus 4x minus 4x gives me 0, plus 18. And then on this side, 6x minus 4x leaves me 2x. Okay? And so that 0 is just sort of, I just to show you that that cancels out. It's just 2x equals 18. And now you have a normal sort of an equation. If you multiply by 2, that's what I'm doing to my variable x. I solve by doing the inverse operation, which is dividing by 2. And if I divide by 2, my multiplying by 2 and my dividing by 2 is 0. All I'm left with is x. And 18 divided by 2 is 9. Okay? And I'm going to really quick show you, because this will be probably the only time I do it on the right side, just to show you that it still works. 6x equals 4x plus 18. I can also move my variable to this side as well. Like I said, you can do it either way. I just prefer to have it on the left side. So I could subtract 6x from each side if I wanted to. And 6x minus 6x will leave me with 0. 4x minus 6x, notice, will give me minus 2x. When I'm subtracting numbers with different signs, I subtract the larger minus the smaller, and then use the sign of the larger number. So that would be minus 2x plus 18.
Wouldn't 0 be x?
No, 6x minus 6x leaves me 0. This is x minus x, 6 minus 6, so I just have 0. And so now I would have a two-step equation on this side, because notice now I'm multiplying by negative 2, and then I'm adding 18. And so to do the opposite of addition by 18, I would subtract 18 from each side. Plus 18 minus 18 is 0. I'm just left with minus 2x. And then 0 minus 18 is negative 18. And then finally, if I do the inverse operation of multiplication by negative 2, I would divide by negative 2. And this was another mistake that a lot of you made on the quiz that you want to be careful of, is your positives and your negatives. So I only took off a point if you had the wrong sign, but you have to be careful. If you're multiplying by negative 2, you have to divide by negative 2. Whatever the number is, you're going to do the opposite of that number. So a lot of you maybe had addition by negative 3, and then you just added 3. But you have to add negative 3. So whatever it is, you have to use that same sign. So negative 18 divided by negative 2 is just 9, because notice, when you're dividing things and they have the same sign, it's going to be positive. And then Multiplying by -2, dividing by -2 is 0. It just leaves me with x. And so x equals 9. Whether you do it on the right or the left is the same. I always am going to try to get my variable over to the left side of the equation. But it does work with both ways. All right. So let's do one together here. 3y equals 15 minus 2y. Okay. All right, Katie. So you're going to do this one with me. So we have our variable on both sides of the equation. So I want to move it to one side or the other. So which side do you want it on?
This. The left side.
On the left side. Okay. So that means I'm going to get rid of it on the right side. What would be the opposite of subtracting 2y?
Addition.
Of 2y. And what is 3y plus 2y? 5y. And then everyone notice, plus 2y minus 2y is all 0. It all just cancels out, and all you're left with is 15. Okay. And I'm going to make a simple onion. How am I going to make my onion here?
You're going to do 5 times this.
Multiply by 5. And so that's the only thing I'm doing. So it's just one little small onion. And what's the inverse operation of multiplying by 5?
Division.
By. And what will that leave me with?
3,
Y equals 3. And notice that if I know this is a smaller one, so it sort of makes sense, but if I put in my 3 over here, 15 does equal 15. And if you take the extra time, most of you finished early, so you have plenty of time on your tests and quizzes. To check that, you'll know that you have the right answer. Okay. Let's get one that's a little more complicated. 4/5 x plus 3 equals x. Now this, when you have this fraction, this made some of you really nervous on the test. You saw 4/5 x and you really weren't sure what that was. And so all that is you have a number here, because 4/5 is a number, and you have an x. These are just being multiplied. Notice there's no sign in between them, so you're just multiplying two things. Okay? So whenever you have anything and there's no fraction in it, that's just that thing over 1. So this is the same as 4/5 times x over 1. Okay? And so when you see it like that, I'll just do it like this. That way you can see it all. When you look at it like this and you put it like that, that may help you to realize what this is. Okay? And so when you're multiplying fractions, once you have two fractions, you just multiply across the top and multiply across the bottom. Now we call that multiplying your numerators and then putting that over the multiplication or the product of your denominator. So 4 times x, you know, is just 4x. 5 times 1 is 5. Plus 3 equals x. And so that may be a little bit easier for you than the 4/5 x if you write it as 4x over 5.
Then what do you do?
Well, next thing you do is you make an onion. So Desiree, look at my x. If you knew what x was, what would be the first thing you would do to try to evaluate that?
Multiplication.
By?
X. No, by 4.
By 4. First thing you do is multiply by 4. So that's what I write up there.
Divide by 5.
Then you would divide by 5. What's the next thing you would do?
Add 3.
You would add 3. So that's how you would make an onion. Okay. So let's start on peeling that onion. And let me move this over just a little this way that we can see. Okay. What's the inverse operation, Felix? What's the first thing I'm going to do here, first of all? How am I going to work this?
-3.
I'm going to subtract 3 from each side. And what will that leave me with, Felix?
4x over 5 equals x. 3.
X what?
X.
3x. What are you doing to your x? Subtracting 3. X minus 3. This was another mistake. Some of you guys changed your addition to multiplication when you were solving these problems. So, for example, if you were subtracting 3, a lot of you were doing that, 3x instead of x minus 3. Addition and subtraction stays addition and subtraction. You can't change them to multiplication and division halfway through. Okay, so you got to be really careful of that. Okay. Tim, what would I do next?
Multiply by 5.
Multiply by 5. Okay, you're going to multiply that on both sides. So I'll just put the little dot there. And how am I going to rewrite that, Tim, so that this makes more sense for us?
4x.
4x. Notice, guys, division by 5, multiplication by 5 just leaves me with 4x. Okay. Now, what am I going to do here? This is a little bit trickier, right, on this side?
You're going to multiply 5 by 3, and you're going to get...
Well, slow down. I'm going to multiply 5 by what?
3x. X minus 3.
By x minus 3. So notice it's this. I'm multiplying it by a quantity. So I'm multiplying 5 by the whole thing up here, okay? Not just one thing. I couldn't say x minus 15. That wouldn't work, okay? So remember, I'm multiplying by the whole quantity. So now what do I have is, what property do I use here? Nathan, what property do I use to evaluate that? Distributive property. Whenever I multiply anything by a quantity, I'm going to use the distributive property. Everybody gets the Snicker bar, right? Everybody gets in there. And my 4x stays there. So Nathan, how will I simplify that? How will I use the distributive property? What's it going to be?
5x minus 15.
5x minus 15. Okay. And now, notice what I have. Now I'm back to very simply what I started with in the beginning. We have a variable on both sides, and we have to get rid of those. Eric, which side do you want to put the variable on?
The right side.
You want to put the variable on the right side. Okay, so you want to get rid of it over here. How am I going to get rid of 4x? What's the opposite? Well, what sign is in front of this 4x? Well, in front of the 4, there's a multiplication here. What's the sign in front of the 4? Is this positive or negative?
Positive.
Positive, because if it was negative, it would tell you. So it's positive. So how am I going to get rid of positive 4x? What's the opposite of positive 4x?
Negative 4x.
So if I subtract 4x from each side, because you want it on the right side, and that's fine, what will plus 4x minus 4x leave me?
0.
0. What's 5x minus 4x?
1x.
And you could put 1x in, but it's just, you can just write x as well, because it's understood, but that's fine. Okay. What am I going to do next, Gianna?
You add 15 to 0.
Add 15 to 0 and to this side too, right? Got to do the same thing to both sides. What am I going to get left with?
15.
Equals
1x.
1x or x. And x is 15 in this problem. Okay, let me go back up. Let me do that. 4/5 15 plus 3 equals 15, because there was the x on there. So, again, notice when I go back, I take whatever my solution is, I put it in for my variable, and then I solve it to see, am I correct? Did I make a mistake? Okay. Alex, what is 4/5 of 15? What am I going to do with that? What does that mean? Multiplication 15 by 4, right? And then divide by 5? Is that what you're saying? What is 15 times 4? 60. 60 divided by 5 plus 3 equals 15. What is 60 divided by 5, Weston?
12.
Linda, what is 12 plus 3? And lo and behold, that does work. Okay, we'll do the same thing, only let's do it in some word problem, because the word problems, I think, is where some of you, or all of you, have more difficulty. So let's try something like number 1. Find a number that is 96 greater than its opposite. Okay. Find a number that is 96 greater than its opposite. What would I do with this, Katie? I'm on page 118, number 1. Find a number that's 96 greater than its opposite. Well, it says find a number, so let's start with that. What do you want to write down for find a number? N. That's always a good one to use because we can just... oh, my daily calibration task.
It's not good. I haven't been doing it like
I
that.
know. Well, we had a test last.
Yeah.
Of course.
Okay.
All that, right? All right. All right, we'll try N. Good job. Okay, so let's find a number. And then it says it's 96 greater. What does that mean?
Addition. 96 plus, right?
Well, I'm sorry, before that, I'm sorry. Find a number that is. So let's start with there. What is? Equals is always going to be, is always going to be the equals. That is. So find a number that is. I'm sorry, now we can start with 96 greater than.
96 plus
Okay. And then what? 96 plus what?
negative n.
Negative n. Because it says its number's opposite. So the opposite of n is negative n. Good. Okay. So first thing we should do is sort of get rid of the plus and the minus together, right? Because that'll confuse everyone. So what does that mean when we add a negative number or add the opposite? What are we doing? That's the definition of what? What operation is that the definition of? We add the opposite.
Not sure.
Subtraction, right guys? If we subtract something, what is subtraction? It's adding the opposite, right? So this is just the same as subtraction. So this is 96 minus n, right? Oh, you're kidding me. Can you see that? Okay. Katie, so now what am I going to do here? You have to get, notice you have a variable on both sides. So now you got to move it to one side or the other.
Yeah. So we're gonna do like 96.
Well, first you want to do something with the ends. You want to
So add in.
you want to add an n to both sides?
Or,
No?
no.
What do you want to do? Hang on one second. Let her finish.
Subtract an
You want to subtract n. Either one would work, by the way, but that's fine. You can add an n or subtract an n in this problem because you have an n on each side. Whether you add or subtract just determines what side you're going to go on. What? It just automatically just keeps wanting to calibrate. I didn't even touch anything. Look at this. All right. Okay. What is n minus n?
Let's
0. What is minus n minus n?
0.
Minus n minus n. You're already at negative n. Think of it on your number line. We're already over there. No. Negative n. You're already at negative n. You're going to subtract. Subtracting another n.
It's doing it to pick
Hang
on
on,
you.
hang on.
Oh, there you go.
Yeah,
I
just,
like you.
I know.
Maybe he just wants you to complete it.
Not valid.
There you go. All done.
I'm sorry. So all the way back.
It's negative 2n.
Minus 2n. You also might want to think of it like this, okay? When there's no number in front of your n, this is really minus 1n minus 1n. So, minus 1 minus 1. When you're adding numbers that are negative, guys, if you're adding two numbers that are negative, you add them together and use the negative sign. So yeah, minus 2n. Okay. So now what do you want to do, Katie? Let's make an onion. Let's make an onion real quick for those who need that. What's the first thing I'm doing to my n?
You're gonna divide.
But you're multiplying by what? 2. Then what? I'm sorry? After you multiply this by 2, what are you doing? Guys. Enough. Let me do it this way, and it might help you more. Let's take it back this way. This may help you more. You remember when it was that, right before I did the subtraction? This is an addition sign. What is addition? What's the property that says I can move those around? If I'm moving them around, I'm making a long commute. What property is that?
I don't know.
Commutative property of addition. That just means that I can move those around, and it may be easier for you to do it like this.
Ah, great.
Joke. This is. I wonder if there's something stuck to the board or something that's making it do that. It's eating up the
Where's
class.
the control?
All right. All right. So now, I'm sorry. So now, what are you multiplying by, Katie?
2. And? Yeah, that. 2.
Negative 2. And then what?
Subtracting 96. Adding 96.
Adding 96. Ask yourself, what are you doing to your n? The first thing you're doing is you're multiplying by negative 2, then you're adding 96. Okay. Now to solve this, Katie, what you want to do is do the opposite. So what's your inverse operation for adding 96?
Subtracting
Subtracting what?
96.
This, by the way, is the reason I like to get my variables on the other side, but that's okay. It works the same both ways, that's why I like to show you that. So what is 0 minus 96?
0. Negative 96.
Negative 96. Equals what?
2 minus 96.
Those cancel out. What are you left with?
2n. Negative 2n.
Negative. And this is what some of you are doing. You're forgetting your negative signs. All right. Then what's the opposite? What's your inverse operation of multiplication by negative 2? Dividing by negative 2. All right, guys. Try the homework. Some of the word problems will trip you up. We'll go over them tomorrow. Make sense to you? Yes?
What are you doing tonight? You will get in that classroom again. Because if I ever see you again, you go in the office and stay there all day. Okay?